ma'am.
Who will tell me amongst you what is the double displacement reaction? Dhairya, are you there? Dhairya? Okay, Abhigya, can you tell?
Ma'am, it's a reaction in which a more reactive element displaces a
Double displacement, double displacement.
It's the exchange of
What
ions,
viewers?
right?
Yes. This is the reaction in which the exchange of ions takes place, right? Ainaja, what is a displacement reaction?
Ma'am, it is the reaction in which a more reactive element displaces a less reactive element.
Good. Priti, how do we decide which element will be more reactive and which element will be less reactive?
Ma'am, because of the reactivity series.
Yes. There, now are you there? There, what is a reactivity series?
Ma'am, reactivity series is a series of metals and like elements in decreasing order of their reactivity.
Very good. It is the series of metals in which the metals are arranged in the decreasing order of their reactivity, right? So in the last class, we discussed many reactions which were related to displacement as well as double displacement, right? Now we are going to go ahead and move to the next topic, means the next type of reaction, which are not specifically there in NCERT, but you should be aware about these also. So I will give you the examples and I will explain you what these means, right? So the next type of reaction which we have is precipitation reaction. Okay. Can Abhinav or Aryan amongst you, anyone tell me what is a precipitate?
Ma'am, the insoluble substance formed after.
Yes, that's absolutely correct. Very good. The insoluble salt is called a precipitate. That's all. That's the definition. So what is the precipitation reaction? It is those reactions which when two compounds mix together, they form an insoluble substance which we call as precipitate. Clear, children? So what is a precipitation reaction? The reaction in which aqueous solutions of two compounds on mixing react to form. What it forms is the most important thing in this particular type of reaction. To form an insoluble compound which separates out as a solid. I will show you one reaction also which I made my children in the school do this, so that we will see on YouTube so that it is much more clearer. Fine?
Precipitate is also formed when decomposition reaction occurs, right?
Yes, when decomposition reaction occurs, most of the time the precipitate is formed. Fine, that is why I'm saying that in the NCERT you are not going to find the term of precipitation reaction, but many reactions which are given in NCERT, which I'm going to just write also one of the examples, they involve the formation of precipitate, and they are amongst those 5 categories which we have out of which we have already discussed 4. So the first example I'll give is, and you can tell me the type of reaction also. It is the reaction of lead nitrate plus potassium iodide. It leads to the formation of potassium iodide and lead nitrate. Which type of reaction is this?
Precipitation reaction.
No, that one telling,
Double
I mean to
displacement.
say, apart from
Double
this,
displacement.
yes, it is a double displacement reaction. Similarly, if I write another example, BaCl2 plus Na2SO4, this on reaction leads to the formation of BaSO4 plus NaCl. These are not balanced, children. This leads to the formation of white precipitate. Now, this is which type of reaction once again?
Double displacement.
Double displacement.
Yes, this is again a double displacement reaction. I'll show you this reaction, the formation of Ki. Fine, because and the other one also I'll show you, because the other one is a part of your syllabus, and the first one in that the precipitate is very much visible. So reaction of lead nitrate and potassium iodide. Let's see this, if at all this is helpful for us.
In the double displacement reaction of lead nitrate and potassium iodide, we have a colorless solution of lead nitrate. We'll add a colorless solution of potassium iodide. As the potassium
Both of
iodide
them are
reacts with the lead
colorless
nitrate,
initially,
we
and
get
this
the
is
formation
how
of
a
a
yellow
bright yellow
color forms
solid,
as
which
soon
is
as
lead
we put
iodide.
the mix both of them. Clear, everyone? When we initially take both of them, they are both colorless. As soon as we mix it, you must have observed how
We have
on
a colorless
addition of only a
solution
few
of
drops,
lead
the yellow
nitrate.
color pops in.
We'll add a colorless solution of potassium iodide. As the potassium iodide reacts
See.
with the lead nitrate,
Clear,
we
children?
get
I'll show you the reaction of barium sulfate also with barium chloride with sodium sulfate.
in the double displacement reaction of barium chloride and sodium sulfate, we start out with a colorless solution of sodium sulfate. When we add barium chloride to it, we get the rapid formation of a white precipitate of
You
barium
can clearly
sulfate.
see again the same thing happened. Both of them are initially colorless, like they look like water, but as soon as we add both of them with each other, you can easily observe the formation of white precipitate. I hope both these reactions are clear to all of you.
Yes, ma'am.
Yes?
Yes, ma'am.
Okay, so
Yes,
let
ma'am.
me
Now
stop
once
teaching, because one second, Abhinav. Because you people cannot turn on your videos, right? Those whose video will be turned off, I will not allow you to sit in the class. I will remove you on. Zoha, RN, Siddhi, turn on your video. Hurry up. Yes, Abhinav, meanwhile, you tell me what you were telling.
nothing, ma'am. Just hold the screen and pop.
The screen is already open. So the next type of reaction, which you will not necessarily see as the name of the reaction in the NCRT, but then again, this is an important reaction which you should be aware about. These names should be known to you, because sometimes in the exam, if they come, so you should not be blank that you don't know the names, right? Neutralization reaction, though we are going to, when we will be done with the entire chemistry syllabus, these names would be very commonly seen to you all. So what is a neutralization reaction? It is a reaction of an acid with a base leading to the formation of salt and water. Always and always, the reaction of acid with the base is considered to be a neutralization reaction, and it involves the formation of salt and water. So it is the reaction of, it could be any acid and any base. Reaction of acid and base to form salt and water is called neutralization reaction. Is called neutralization reaction. Clear, children?
Yes, ma'am.
So I'll give you a few examples for these also. Okay, you can tell me any acid or base. Anyone? Any
Hydrochloric
acid
acid.
first of all? Hydrochloric acid. It can be HCl. Then any base, anyone? Sudhamshu? Do you know any base? No base you don't know. Okay. Meher, do you know?
No, ma'am.
Abhigya?
No, ma'am.
This is of class 7. You start studying this chapter in class
Ma'am,
7. Aryan, do you know? Abhinav, just wait.
Ma'am, sodium hydroxide.
It is NaOH, one of the most common examples. It leads to the formation of NaCl plus water. Okay, and apart from that, I'll give you a few more examples, one or two more examples. We can take the example of ammonium hydroxide, that's the base. It reacts with acid H2SO4. It leads to the formation of NH4 whole twice SO4 plus water. Clear, children? This is the salt. Water, you are already aware. This is the base, which is known as ammonium hydroxide, and sulfuric acid is already known to all. This is what I think. I don't know if you know or not. This is hydrochloric acid. This is your sodium hydroxide. This is your sodium chloride. Water is already known to all. The name of this salt is ammonium sulfate. Anyone has any doubt in the two reactions I have just taught?
Ma'am,
Yes.
vinegar and baking soda is also a
Example of,
utilization, right?
yes, because vinegar is acid and baking soda is a base. Any acid, any base reacting with each other, they lead to the formation of salt and water, and this reaction is neutralization reaction. Why it is neutralization reaction? Because the salt which is formed, it is neutral in nature. It is neither acidic nor basic in nature. Clear, children? Okay. Now let us move further to the last reaction of our syllabus, which we are supposed to do. That is the redox reaction. So first I'll explain you what redox reaction is, and then later we are going to study the terms which will be included in the definition of redox reaction. So you see there are two terms in this one particular term. Let us look at both the hidden things. This. So what is redox reaction? It is the reaction in which oxidation and reduction occurs simultaneously. What does this word simultaneously means? It means it occurs at the same time. It occurs together. Is called redox reaction. Now, if you look at the word redox, you can see RED, it has been taken from reduction. OX is taken from oxidation. Both of them occur together, and that is why we call this reaction as redox reaction. Now, what is oxidation? What is reduction? Let us see and let us discuss about oxidation and reduction. Then we will see the example of redox, not before that. Meher, you are able to understand what I'm teaching?
Yes, ma'am.
Sure, because I'm going to ask the questions when I finish teaching.
Yes, ma'am. Okay, ma'am.
Oxidation reaction, the reaction in which there are two possibilities. Either of them is going to happen in the case of oxidation reaction. Either the gain or addition, any word you can write, addition of oxygen takes place, or the other thing would be the reaction in which the loss or removal of hydrogen gas takes place.
What about
Clear,
the
children?
electrons?
That is another thing I will tell you. Wait. Clear, everyone? This is the most basic definition of oxidation reaction. Okay, I'll mention about the electrons also, but chalo, I'll write. In case of oxidation reaction, the loss of electrons takes place. For this, you need to know a lot of things if you know this definition. The reaction in which the loss of electrons takes place, that's also known as the oxidation reaction. Then comes our reduction reaction. Exactly opposite what is happening in oxidation will happen in the reduction reaction. So the first thing would be the reaction in which first thing would be the loss or removal of oxygen. Fine, children. Then second thing would be gain or addition of hydrogen takes place. And lastly, when the gain of electrons occurs, then we say that the reduction has taken place. I hope the definitions are clear. I can move to the examples to show you where oxidation occurs, where reduction occurs, and when we call them as redox reaction. So let us take the first example. 1 second, children. This gets hanged. I think the file is so heavy. Okay, so first example is CuO plus hydrogen getting converted into Cu plus water. Everyone will look at the screen for once, because to understand you should first listen. Later, if you wish to write anything, you may. So if we check for the copper oxide, it has converted into copper on the product side. We can clearly see that the removal of oxygen has occurred in this particular case. So when the removal of oxygen occurs, we call it as reduction. Whereas if you look at hydrogen, it has converted into water. It has gained oxygen, or we can say that addition of oxygen has occurred to hydrogen. So we call this particular part as oxidation. And together this entire reaction is known as a redox reaction, because oxidation and reduction both are occurring together. Any doubts still here?
Ma'am, is hydrogen
Anyone?
more reactive than copper?
So,
Yes, hydrogen is more reactive than copper.
so
Okay.
ma'am, reduction and oxidation are interlinked.
Yes, they are always interlinked.
So there's
Wherever
no
there is oxidation occurring, there is always a chance that there would be reduction. And or we may say vice versa, that wherever reduction is happening, oxidation is surely going to happen. Even sometimes, like if I take the example of this particular reaction, this you are not going to observe the gain or loss of hydrogen. A second, children. Can anyone speak for a moment?
yes.
Yes, ma'am.
I cannot hear. Children, just give me a moment. I don't know what has happened to my device. I'm unable to hear. Just give me a second. I'll be back. You can meanwhile revise the definition of oxidation and reduction. Just give me a moment. Okay, children. I hope I am audible. And can anyone speak for a moment so that I can see if you are audible to me or not?
Yes, ma'am.
No, you are fine. Okay. So yes, I was telling about one example where we are not going to see the oxygen removal or addition. So let us see this example. This is CuSO4 plus iron. This gives us FeSO4 plus copper. See children, what example I'm writing now, if you're able to understand this particular type of redox, then fine. Otherwise, this is the type of redox which is going to come in class 11. But since Abhinav had mentioned the electrons, that's why I'm explaining this example also. Even if you do not consider this example, it's not at all a harm for it. Fine, children? Now let us understand. For understanding how this is a redox reaction, there are two things you should know. First, that any substance in elemental form, means when it is present in the form of element, in elemental form has, now there is another term which I have to write which you people don't know, or I'll write it only, has oxidation number 0. I will tell you in short what you can understand our oxidation number as. And then other elements when we have to find oxidation number of any element, in a compound, means whenever a compound is there, of that we have to find the oxidation number of the element which is present in the compound. Then we consider its valency. Then its valency is considered as its oxidation number. Now children, for now you can understand that the oxidation number is related to valency for now, but it is not actually. And in case of elements, we will consider, I have written 2. I'm sorry, it's 0. It's not 2, it's 0. The oxidation number is 0. The oxidation number is 0. It's not working at all. Fine. Now let us see here. So in case of iron, it will be 0 over here. And in case of copper also, it will be 0 because iron and copper both are in the form of elements. Now if you look here, CuSO4, what is the valency of sulfate ion? 2. So to find the valency of copper, how do we find? We consider it to be X and sulfate's valency is -2 equals 0 because there is no overall charge on the compound. So what will be the oxidation number of copper? It will be +2. If we consider about FeSO4, same thing we will consider for iron as X. Sulfate is again -2. Overall, there is no charge on the entire compound. So the oxidation number of iron also comes out to be +2. Is it clear? Now let us see the change in the oxidation number. So if we see the change in the oxidation number of copper, it has changed from +2 to 0. Means the oxidation number has decreased, right? Whenever
Yes,
there is
ma'am.
decrease in oxidation number, we call it as reduction. Whereas if we look at iron, Fe converting into Fe+2, the oxidation number has increased. Whenever there is increase in oxidation number, we call that process as oxidation. So this
Oxidation
is, yes.
gaining, like the number gaining is, can we compare it to gaining of electrons?
Wait, Abhinav, I have not finished yet. Wait. So first thing is to find out the oxidation number in such cases where it is not clearly visible the gain of oxygen or the loss of oxygen or the hydrogen, right? First thing we have done is to find out where the oxidation is happening, where the reduction is happening using the oxidation numbers. For finding the oxidation number, only these two things you have to remember. Now you are saying, ma'am, you were mentioning about electrons, where we are able to see the electrons, right? So we will see the first of all, we will see Fe getting converted into Fe2 plus, right? Did I write anything wrong? Are you able to understand?
Yes.
Now Fe2 plus means it will have to balance the number of the charges on both sides. It should have 2 electrons, right? And the
Yes, ma'am.
copper was in +2 state in the reactant side and it got converted into copper. So where the electrons needs to be balanced to balance the overall charge on the reactant side. Yes.
Yes,
So
ma'am.
what did I mention about oxidation? The gain of electrons or the loss of electrons?
Loss.
Everything has the loss of electrons. And what about reduction? What did we mention? The
Gain of.
so if you look at this, we can see the gain of electrons.
Yes, ma'am.
So this is what? Reduction. That's what we mentioned also. Whereas here the electrons are on the product side, means the electrons must have been subtracted from the reactant side. That's why they came on the product side. So it is basically the loss of electrons. That's why it is the oxidation reaction. Clear?
Okay. Yes.
Clear to everyone? Such examples are not very common till class 10, but in class 11, as I mentioned earlier also, that redox reaction is an entire full chapter in class 11th if you opt for science. So this is how this happens in case of the electron. Clear, children? Any doubts still here? Can I move further?
Yes, ma'am.
Okay. I request you all to keep your videos turned on. Again and again, I am not going to repeat this, please. Now we have another important terms. The first term is, because in the exam, 4 things are asked together. First is, I will tell you what 4 things. 2 we have already studied. The next 2 are these 2. First is the oxidizing agent and the next is the reducing agent. So what is oxidizing agent? It is the substance, it is the substance which oxidizes other substance and itself gets reduced. Now, what about the reducing agent? It is the substance which reduces other substance and itself gets oxidized. Now we are going to observe the oxidizing agent and reducing agent in the same example which we took earlier. CuO plus H2, it gives us Cu plus H2O. And we have already discussed that conversion of CuO to Cu is reduction, whereas the conversion of hydrogen to water is oxidation. Right? Now we have to identify the oxidizing agent and the reducing agent. And there are two other things which are asked. Substance oxidized and substance reduced. These are the four things which are asked in the paper. By giving the reaction, they are going to ask that you have to tell which is the substance oxidized, which is the substance reduced, which is oxidizing agent, which is reducing. So first of all, you can clearly see wherever the oxidation is happening. First of all, you have to remember that all these four answers are from the reactant side always. Okay? Now, which will be the substance oxidized, which is undergoing oxidation? So it will be hydrogen. Which will be the substance reduced, which is undergoing reduction, copper oxide. Now, what will be oxidizing agent? Which is reducing others and itself getting oxidized. So the substance which is reduced is the oxidizing agent, whereas the substance which is oxidized is the reducing agent. It is always the opposite. You will be easily able to find which is the substance oxidized, which is the substance reduced. Looking at that, you can write what are the oxidizing agent and the reducing agent. Clear, children? Any doubts still here?
No,
No,
ma'am.
ma'am.
Now I'm giving you all one question and you are going to tell me all these four things in this. And nobody will utter the answer. We have to wait for 2 minutes. Fine. This is the equation. You have to tell me four things. Substance oxidized, substance reduced, oxidizing agent, reducing agent. Well, I'll give you all 1 minute. Meher, one answer I'm going to ask from you. You just keep on sitting and looking at the screen. It seems like you do not write anything at all.
Am I right?
I don't know what you write and where you write. I'm going to ask the question from you, not try. Everyone has to try.
Yeah, ma'am.
Sudhamshu, Dhairya, Zoha, Sai, Siddharth, Siddhi, keep your videos turned on. Sai, Siddharth, I don't even know who you are because in the last class you joined, you did not unmute. Now also you are not unmuting yourself.
Ma'am, I have a problem with cameraman, that is why.
Okay, so at least you should interact. I don't even come to know that you have joined. But are you able to understand whatever I am teaching in the class?
Yes, ma'am.
Any doubts you have from the previous classes, you can ask from me.
Okay, ma'am.
Okay. Zoha,
Yes, ma'am.
what has happened to you today? No response.
Ma'am, my camera is not working again today, ma'am.
You all should message in the group. You are already aware about it. Dhairya and Sudhamshu, keep your video turned on.
Yes, ma'am. 1 minute, ma'am.
Okay, I think by now you must have done this. Meher, I'll ask from you. I'll start from you. First of all, you tell me where is the oxidation taking place?
Ma'am, at ZNO. I mean, like
Hmm.
carbon. At carbon.
Clearly tell me, ZNO or carbon? You have
Carbon.
spoken both. Yes,
Carbon.
that's correct. The conversion of carbon to carbon monoxide oxidation is occurring. Why? Because carbon is gaining one oxygen. Then, Sai, can you tell me if where is reduction happening? Sai, Siddharth, can you unmute yourself and tell me where the reduction is happening?
Ma'am, the substance reduced is
No, I'm not asking substance reduced. Where reduction is happening?
ma'am, ZNO to ZN.
Right, very good. The conversion of ZNO to Zn is reduction. Dhairya, now can you tell me which is the substance oxidized?
The substance oxidized is carbon.
Right. Dhriti, can you tell me which is the substance reduced?
Ma'am, ZNO.
Good. Aryan, can you tell me which is the oxidizing agent?
ZNO.
Good. Abhinav, can you tell me which is the reducing agent?
Carbon.
Carbon. Any doubts, anyone? Let us do one more question. The screen has hung. One more question. ZH2S plus Cl2, it gives 2HCl plus sulfur. Again, these four things are to be discussed. Substance oxidized. Now I will not wait for much time. So hurry up. Meanwhile, I finish writing all these four things. Anija, I'm going to start from you. Anija, can you tell me where the oxidation is taking place?
Ma'am, Cl2 Cl2 2HCl.
Is oxidation.
Ma'am, can I?
Wait. Okay, Abhinav, tell me.
H2 to S.
H2S to S. The removal of hydrogen is happening, means it is oxidation. Whereas Cl2 to HCl, the addition of hydrogen is happening, so it is reduction. Now, who will tell me? Meher, can you tell me the substance oxidized?
Ma'am, chlorine. I
How
mean
come
sulfur.
chlorine?
Sulfur.
Sulfur is on the product side. Product side is never the answer.
H2S.
It is H2S. Then Aryan, which is the substance reduced?
Ma'am, this Cl2.
Dhriti, what is the oxidizing agent?
Ma'am, Cl2.
And Here, what is the reducing agent?
Ma'am, the reducing agent is H2S.
S.
Yeah, H2S.
Right? So we will continue in the next class. Revise till here. And I'll see you all in the next class. Then we will discuss the other topics of the chapter. Fine. Have a good day, everyone. Bye, children.